Guys, in this video, we are going to discuss the problem coin piles, which is a problem from CSES problem set from introductory section. So let us first read the problem statement. So time limit is 1 second and memory limit is 512 MB. So the statement is here you have two coin piles containing A and B coins. On each move, you can either remove one coin from left pile and two coins from right pile, or two coins from the left pile and one coin from the right pile. The task is to efficiently find out if you can empty both the piles. The first input line has an integer t, the number of test cases. After this, there are t lines, each of which contains two integers a and b, the number of coins in the pile. Output for each test print yes if you can empty the two piles and no otherwise. Constraints are t is between 1 and 10 to the power 5, and a and b are between 0 and 10 raised to the power 9. So this is the sample input, and these are the sample output for the sample input test cases. So let's discuss about the approach. So approach will go as follows. So we are given piles of A coins. So we have two piles. First contains A coins, contains B coins. So and the move order is if two coins in from A, then one is taken from B, and else if one coin is taken from A, then two are taken from B. So guys, uh, here we can assume let there are, so if we divide the number of pickups, so let there are x pickups in which two coins are taken from A and one is taken from B. Why be the pickups in which one is taken from A and two is taken from B. So guys, the according to the question, we can write this equation A minus 2x, for because there are x processes in which two coins are taken from A and one is taken from B. So A minus 2x are such to x, so x times two coins are taken from A, and y times there are one coin taken from A, because y is the number of processes in which y is the number of process in which one coin is taken from A. So we can rewrite the equation as A is equal to 2x plus y. We can similarly create a similar equation for B. So B minus x plus minus 2y is equal to 0. So B is equal to x plus 2y. So we can solve the variables x and y. And we need to remember one thing here, that x and y are whole numbers, because there's a number of pickups, so they need to be either 0 or a positive integer other than 0. So they can be the total whole numbers in total, and x and y should be whole numbers in this scenario. So on solving these two equations, that this be equation A, and let this be equation B. We can say that x is equal to 2a minus b by 3 and y is equal to 2b minus a by 3. So these are the solutions for x and y, and the solutions are valid if value if x and y are greater than equal to 0. So, and x and y are whole numbers, we can say. So x and y are whole numbers, it means 2a minus b mod 3 is equal to 0. And I mean the remainder when 2a minus b is divided by 3 should be 0, and 2a minus b is also greater than equal to 0. So same condition goes for b. 2b minus a should be greater than equal to 0, and 2b minus a mod 3 should be equal to 0. So that is all for the approach, guys. If these conditions are fulfilled, then we need to print yes, otherwise no. Now we can move to the code section. The code goes very simple. We just first need to take the input number of test cases. Now for each test case, we are given two integers a and b. So we just need to input them. So let's divide a variable x, define a variable x. X is equal to 2 times a minus b, as we have discussed in our approach. And let's define a variable y, which stores 2y, 2b minus a. So in our approach, we discussed if x mod 3 is equal to 0 and y mod 3 is 0, and x is greater than equal to 0 and y is greater than equal to 0, then in this case the solution is yes. We need to print yes simply. Else we simply need to print out. So that is it for the approach, guys. I think we can now copy the sample input and write a code to run. So we have our output yes, yes, no, yes, which matches the sample output given in the question. I think we can submit the solution, guys. And it is accepted. So that is for the question, guys. I hope you were able to understand the question and able to apply the equations. That's all from my side. Thank you.